Alright, so we want to prove this identity first, so let's pretend we've written it out, and then we're going to say something like left-hand side, maybe right-hand side is easier, because we're just expanding, and I'll talk through a lot of this so I don't have to write it. So we know that the expansion, I think it's in your formula book as well, of sine A plus B is sine A cos B plus cos A sine B, and then minus, same thing here. So if we're going to prove it or show it clearly, we'll do, oops, I just sine minus B cos A. Alright, so using the fact that sine is an odd function and cos is an even, oops, looks like a T, is an even function. So because we know sine is an odd function, sine of negative b will be negative sine of b. And because we know cos is an even function, cos of negative b will equal cos of b. So using that here, we'll get sine A cos b for this one. And this one, of course, will be negative sine b cos A, but there's a negative out the front, so that will end up being positive sine B cos A. Okay, so you can see that this one and this one will cancel, and this one and this one are the same, so we're going to get two of those, 2 cos A sine B's. Alright, and we're going to use that. So remember, we are looking to use that in the next step. So of course we would say let P of n represent the proposition. P of 1 is true, since now when you put 1 in, it's a series, but when you put 1 in there, you get cos of 0 theta. So we're looking for no causes. So we're just looking for that half there. So it's a half plus. So on the left-hand side, you would get a half. On the right-hand side, when we put 1 in, let's check. So we do get sine of 1 minus a half is a half theta, and 2 sine a half thetas, so they cancel and you get a half again. So both sides we're getting a half, so P of 1 is true. Our assumption is for some integral k is greater or equal to 1, we are assuming this is true, that a half plus cos theta all the way up to cos k minus 1 theta is equal to sine k minus a half theta over 2 sine a half theta. Alright, so what are we required to prove? We're required to prove our P of k plus 1. What is our P of k plus 1? Well, it's all the way up to our k term, which was cos k minus 1 theta, but we're adding another theta, so all that's the same as before, but we're also adding the next term, which is, if we put k plus 1 in, you can see we'll get cos of k theta. So we're required to prove that it's equal to sine of, now k plus 1 means that minus a half is k plus a half. And we've still got 2 sine a half theta on the bottom. Alright, so if we take that left-hand side, and again, I'm skipping lots of steps here, but that left-hand side, that whole part here is straight from our, if we do use our P of k, we know that part is equal to sine of k minus a half theta on 2 sine theta on 2. So we know that. But we're also adding this term cos k theta. That's by itself. Now if I want it to be have a common denominator, I'm going to put it on 2 sine theta on 2. So therefore I have to times it by 2 sine theta on 2. Alright, so now we've got the 2 sine theta on 2 that we want on the bottom for everything. So that's all good. And on the top, at the moment we've got sine, so we want to get rid of this, so hopefully when we expand this will disappear. And here is where we can use, if you have a look, we can use our identity. So here we've got 2 cos a sine. So in this case, our A is that k theta. I'll write it here for us. And our B is theta on 2. So if I use the expansion, what is that going to give us? It's going to give us sine of A plus B. So we've got k plus a half theta. And sine of, so minus sine of A minus B. So k minus a half theta. So it looks like that's where we're getting rid of the front term. So this term and this term will cancel, and we'll be left with what we want, which is our sine k plus half theta on 2 sine half theta, which is our right hand side. Okay, so it is what we want. So then, of course, we do our P of k implies our P of k plus 1, therefore P of n is true for all our n, all our integer n is greater or equal to 1.